Bismillahirrahmanirrahim. We have discussed paging in previous lecture. So in this lecture, we will discuss our next topic, that is segmentation, which is a similar concept like paging with slight differences. Segments are also created of user programs the way pages are created. So in today's lecture, first topic that we are going to discuss is segmentation. What actually segmentation is and how they are created. So let's start our lecture. When a program is divided into chunks of unequal sizes, those chunks are known as segments. While pages were of equal sizes, as we discussed in previous lecture. So a process may have different segments of varying sizes, and they can be loaded anywhere in main memory. That means all the segments of a process need not to be in sequence when loaded in main memory. Every segment has instructions and or data, and there is no internal fragmentation in segments. But external fragmentation may be observed if a segment size may not match the size of the main memory partition. But this problem may be reduced if we use small size segments. Segments are visible to programmer because programmer designs the segments by dividing his program in different functions. While pages are not visible to programmer, segment table is also maintained by operating system, and every entry of segment table contains two information. The information include the starting physical address of that segment and the length of that segment. The length of the segment or size of the segment is required because segments are of varying lengths. And this is also required for the protection of different segments from segments of other processes in main memory. It is advised for programmer to keep the size of segments small. That means functions in a program need to be made of small sizes. Now we are going to discuss address translation using segmentation. How logical to physical address translation happens in segmentation. When a process starts execution, the CPU register is loaded with the starting physical address of the process segment table. The logical address of a single instruction within the segment is made up of to information as mentioned previously. The information include the respective segment number and the offset within that segment. This constitutes the logical address. Offset again here represents the relative address or distance of instruction from start of the segment. CPU then searches the segment table to obtain the starting physical address of the segment and its respective size. The respective physical address is generated by adding the offset with the starting physical address of the segment. The offset of a single instruction is then compared with the size of the segment to ensure if the instruction resides within the range of the segment or not. This is done for the protection purposes to ensure that the reference instruction is within the logical address space of a specific segment. The diagrammatic representation of the translation process is now in front of you. CPU generates the logical address. Here is the logical address consisting of segment number and offset within the segment. The segment number is indexed with segment table to obtain the starting physical address of that segment along with its size. So here segment table is searched out to find the starting physical address of this particular segment and its respective size. Once the size is obtained, then this offset gets compared with this size to see if this instruction is residing in this particular segment. If it is part of this particular segment, so the offset then gets added with the starting physical address of this segment in order to obtain the actual physical address of the instruction in main memory. But if the offset is not within the range of the segment, so an interrupt is generated. If it is not within the range, an interrupt is generated for operating system to inform that it is an illegal instruction that need to be aborted. "16 bits logical address is translated in 16 bits physical address. The starting 4 bits of logical address shows the segment while the remaining 12 bits show the offset. The segment is indexed with segment table to get the starting address of segment and its size. The offset gets compared with its size, and if it's a legal or valid instruction, it gets added with the starting physical address of the segment to get the physical address of single instruction, which is again in 16 bits. Now we are going to discuss the differences between paging and segmentation. This is our next topic of discussion in this lecture to find out what is the similarity and differences between paging and segmentation. Some comparisons are made between paging and segmentation. You all must know that segments and page both are formed from a user program or a process. So the first major similarity among both is that they are made up of processes, or in other words, user tasks. But since segmentation is done by a user or programmer, so the hardware required for the address translation in segmentation is more complicated as compared to paging, because user has freedom to decide the size of his or her programs. So the address translation, as we discussed in previous slides, gets more complicated task for the operating system, as user segment size may variate time to time. But since pages are made up of user tasks and this is done by operating system itself, so the address translation in paging is simple as compared to segmentation. You might have noticed the differences in the address translation mechanism of both the techniques. Address translation of paging was quite simple, while the address translation of segmentation is little tough, as we have to also compare the size of offset or the offset with the size of segment table to ensure that this is a valid instruction. Paging is thus not visible to the programmer, but segmentation is. As we have already said, user makes segments himself. Another difference between the two is that segmentation has external fragmentation, as we have already discussed while we were discussing segmentation, while pages generate only small amount of internal fragmentation. We have already discussed how internal fragmentation can be generated in paging in our previous lecture. So segmentation suffers from external fragmentation, while paging may generate very small amount of internal fragmentation. Segmentation actually is the treasure for programmer to organize his programs. So protection is provided in segments in shape of the size, as we store the size or length of every segment in every segment table. While protection in paging is provided using valid and invalid bits. We have already discussed what is valid and invalid bits in previous lecture while we were discussing paging. So protection is required both in paging as well as segmentation. In case of segmentation, we provide the size or length of every segment for comparison with every instruction in order to see if the instruction is valid instruction or an illegal instruction. While with paging, there is a valid invalid bit with every page. In order to confirm a reference page is an legal page or an illegal page. While you also know that segments and pages are made up of user task, but segmentation is of varying sizes while paging is of same sizes. So this is all the comparison that we make between the two. That is all for now. I hope you might have understood how paging and segmentation work on your tasks and what is the difference between the two. I thank you all.